So again, this is Rick Price from Pittsburgh Region Clean Cities, and we're putting this on with our counterpart, Tony Bandiera, who's the Executive Director of Eastern Pennsylvania Alliance for Clean Transportation. And today our presentation is on Charger and Energy Management 101. And our guest speaker is Elizabeth Hughes, who's a sales engineer at the Mobility House. Prior to the Mobility House, she worked at General Electric, including various positions of their power grid division and focusing on the intersection between commercial and technical realms. Elizabeth is focused on helping customers understand their products and unique advantages for creating an understanding regarding how to solve challenges. She holds a BA degree in electrical engineering from Rochester Institute. I am going to go ahead and turn this over to Elizabeth. Welcome, Elizabeth.
Thank you. Thank you for having me. And thank you, Pittsburgh Regional Clean Cities, Eastern Pennsylvania Alliance for Clean Transportation, and Drive Electric PA. As Rick said, I am the sales engineer for the Mobility House. And so I'll just start out really quickly on, what is the Mobility House and why am I talking to you here today? The Mobility House was founded in 2009 in Munich, Germany, and we really play kind of in the Venn diagram intersection between the energy industries and the transportation industry. And what does that mean? Well, we do a few things, including vehicle to grid integration, stationary storage and energy trading, as well as some consulting. But what I'm really here to talk to you guys and focus on today is charging energy management. And in that space, our solution is called ChargePilot. And it's the world's leading charging and energy management platform designed for fleets. And today, throughout the presentation, you'll hear me mention ChargePilot is because I'm going to use it as an example of a charging and energy management system. It is by no means the only one, but I am a little biased and it is my favorite and the one I know the best. So with that stated, let's cover what is charging and energy management. Well, charging and energy management is a type of load management. And when we say load management, we're really talking about electrical power and its control. Specifically in charging and energy management's case, or CEM, we're talking about the power that is used to charge electric vehicles. Now, a lot of people may not realize that they're actually already familiar with a different type of load management, and that would be a smart thermostat. So a smart thermostat, its goal is to regulate the temperature of your house using heating and cooling to hit a specific temperature as cheaply as possible. Charging and energy management does basically the same thing. Its goal is to reduce the cost of charging while still making sure all vehicles are charged as much as you want them to be. It is often an overlooked aspect of charging of the charging ecosystem because it generally costs less than the main infrastructure components like a vehicle or a charger. However, its effects trickle down to the design, planning, and implementation of everything else. So charging and energy management can range from simple systems that just say, hey, don't charge between the hours of 8 p.m. and 9 p.m. to something as complex as ChargePilot that is dynamically adjusting to changing variables in real time, that can assign priority to vehicles, and that is really working to optimize around your utility rate structures. But with that being said, throughout the kind of charging and energy management space, what we're really trying to do is spread out the energy load. And we're trying to spread out the energy load because it is a lot cheaper to basically have power and buy power over a period of time rather than all at once. For example, 10 kilowatt hours bought over the course of an hour will cost drastically less than if you receive that same 10 kilowatt hours in a 15-minute period. And the graph you see on the slide is actually a really good example of this. We can see that the red spike is an unmanaged charging scenario, or a scenario that doesn't have CEM. It's supposed to represent a scenario where the vehicles come back during the day after working all day, they get plugged in, and all of them are charged at the highest rate possible to 100%. And you can see that we get this huge spike of power that goes up to 3,256 kilowatts. And that number is actually the peak load, or the highest instantaneous power requested by the site. And we can see that in a managed charging scenario, right, where we're trying to levelize that use of electricity, we are able to reduce that almost by 3 times. And that's important because it's going to drastically affect the cost of that electricity, but it's also going to make it so that you don't need as much grid infrastructure to service that need. And that is because grid infrastructure is sized based on that peak load, or that 3,256. And obviously, grid infrastructure that can handle 3 times more power will be more expensive. So with that being said, what does charging and energy management allow you to do? Well, we just started talking about some of the fundamentals of how it helps you control energy costs, and more on that later. And we just also talked about a little bit about how it lets you get the most out of your grid interconnection. It also helps you maximize reliability because it can show you the errors, it can show you the usage rates of your various chargers and help you pre-plan your maintenance. It helps you plan for scale because you can see, how much of my available power am I using on a daily basis, and what is really my utilization rate of my chargers. It can help you, if you pick the right third-party charging and energy management software, be able to pick chargers and use chargers from various different, OEMs. I will put an asterisk on my statement there, where certain charger manufacturers require you to use their charging and energy management software. So this is something you want to kind of pay attention to. It also gives you access to your data, both live and historically, and then also a lot of charging and energy management systems allow you to integrate with other third-party software. So with all that being stated, charging and energy management is critical to the success of fleet electrification, and that's because it affects all aspects of your planning and your build out. In terms of your charging hardware, it would affect what type of chargers you want to buy and making sure that they are agnostic and able to be controlled by any party. It would also affect the ratio of chargers to vehicles. Generally, without a charging energy management software, you're going to end up with a 1-to-1 ratio, 1 vehicle to 1 charger. With a charging energy management system and some consulting work that goes along with it, you could bump that up to, I've seen as highest as 3 to 1, meaning 3 vehicles to 1 charger. That really cuts down on the amount of construction that you have to do and the amount of planning and work that goes into the design and construction of your site. It also will affect your operations and maintenance because you are going to have a better insight into not only the day-to-day life of your chargers, but also any errors that come up. And you're also going to be able to drastically reduce, the average cost of your energy month on month. And I've just put some key takeaways for you to look at, after this presentation is done on the side to kind of show how really just like a tree, the best time to think about charging and energy management was a few years ago. The second best time is now. So coming at it from a bunch of different sides and moving into EV project costs, I want to talk about some important concepts that I think lay really the groundwork to understanding what we're attempting to do. So in review, charging and energy management is trying to avoid scenarios where you plug in all of your vehicles all at once and they go full tilt and try to charge your vehicle from 0 to 100% state of charge as fast as possible. And we're trying to do this to reduce your peak because utilities in their rate structures have these things called demand charges. And what they do is they find the 15-minute window period of time where you use the most amount of energy, say in a rolling 6-month period, and then they multiply that amount of energy by a fixed fee to give you this thing called a demand charge, and that is applied to your bill every single month for that next 6 months. So say, it was $2,000 because, you had a 15-minute window where, your kid all of a sudden turned on all the lights on in your house and you know, turned on the computer and turned on the heater, or, you know, in a charging scenario, you know, you plugged in all the vehicles all at once. Now you're going to get charged for that same amount month over month over month, until either you set a new high peak or that 15-minute window is no longer in that rolling time period. Another thing charging and energy management is going to attempt to do is it's going to try to avoid time of use rates. A lot of people have heard the knowledge or the colloquialism, like, you should do your laundry at night. And the wisdom in that is that electricity for certain utilities tend to cost different amounts throughout the day. Generally, it costs the most when people are getting ready for work and right when they come home from work. And usually the middle of the night is the cheapest. However, that might not be the case. But the reason you do your laundry at night is because the electricity is the cheapest, thereby lowering your average cost. And we want to really try to do activities that use a lot of electricity, like charging vehicles, at those lower time of use rates. Another thing you might hear really often in this space is V to X. And what I mean by V to X is it could be V to and then any sort of other letter. It could be G for grid or B for building. And really this means vehicle to X. So you are sending energy back from your vehicle battery to the grid or the building or something else. And then kind of taking those concepts and really breaking them down in your overall EV project costs. You have your ongoing operational costs, and that's really your utility bill and your utility rate structure. And that usually has a total energy component and then also a demand charge component. And your total energy component really is made up of the amount of energy that you use and the average cost of energy. So the amount of energy is reduced by charging and energy management by not trying to always charge your vehicles to 100%. And the average cost of energy is reduced by avoiding those time of use rates. And then for the CapEx side of things, you usually can get away with less grid infrastructure because you are lowering that peak load, allowing you to use cheaper grid infrastructure. And then also, if you don't have to do an expansion or you have to do a smaller expansion, usually that saves you time on your grid build out. This is a high-level system diagram of ChargePilot, but what I'm going to do with it is I'm going to walk you through the various kind of subcomponents of a charging and energy management system that you'll normally see, starting with your EVSEs or electric vehicle supply equipment. Generally, you want to make sure you're picking agnostic types of chargers. Charging and energy management has a role to play, whether it's AC chargers, DC chargers, plug-in chargers, or overhead pantograph chargers. And then usually these chargers are somehow connected to where the intelligence lives. In ChargePilot's case, this is a hardwired connection, as it's more stable than a Wi-Fi based connection. And it's connected to our local controller. And that's where kind of the dynamic adjustment and the local intelligence lives. In certain other charging and energy management software, there would be a direct connection from the EVSE to the back end. And when we say back end, we usually are talking about some sort of cloud-based infrastructure. And if you are looking to do some sort of RFQ in this space, this is where you're going to really want to get your IT team involved, as the type of connection from the site to the cloud instance drastically be affected by whether you need to use a cell system, which is more expensive, but it is more, secure from an IT perspective, versus an Ethernet connection, which is cheaper, but, might have your IT team a little nervous as you have to, either open up various ports or whitelist certain sites. So that is something to keep in mind. Also, they'll probably be interested in how the data is stored and how it's encrypted. Another thing that you'll see in a lot of charging and energy management systems is a web portal. And usually this web portal will give you insights into both live and historical data. And hopefully, if you have more than one site, we'll have a multi-site view. Most charging and energy management systems right now have a data connection to their chargers. Although I have seen a few come out with a power connection. Generally, those are more expensive and require you to use their hardware, and aren't as agnostic, as well as they have to usually fall into line with local national electrical codes. So just a pro tip there: if the charging and energy management system that you're looking at has a direct influence on the power, it's probably going to be more expensive, and you're going to need to involve the utility even earlier in the process. For the rest of the presentation, I wanted to kind of do a deep dive on some of the lessons the Mobility House has learned on some of the more complex topics in this space. And I wanted to start out with, how important the ecosystem surrounding a charging and energy management system is. There are a lot of companies that were around 10 years ago that aren't around today. And while I hope every single company that's around today is around in 10 years from now, that's not something we can guarantee with a space as growing and as new as this one. And so I kind of always like to joke that, companies may live or die, but engineering standards are really hard to kill. So when you're thinking about how your charging and energy management system plays in its ecosystem, you want to pick one that uses open standards. You do that for future-proofing reasons, but it also gives you the flexibility to expand and pick different suppliers over time. And so I've done a quick selection of a few different types of communication standards that are generally widely used in the industry, starting when talking about third-party softwares such as scheduling tools or OEM backgrounds. You'll hear the term API talked about a lot, and API stands for Application Programming Interface, and really it's just a type of software that allows one software to exchange data with another one. You're going to want to ask your charging and energy management supplier, is it an import? Is it an export? What type of APIs do they have? Because there are different kind of forms of API. For example, a REST API is one type of form, and an open API is a different type of form. Moving on to like the grid side of things, what's mostly going to happen over here is you're going to have to think about demand response events, or when a utility, if you decide to participate in a demand response program, will lower your ability to use power. And if you decide to participate in these events to get savings on your bill, they are going to have to integrate with your software somehow. There's a wide range of technologies playing in this space, everything from pre-planned, demand response events that are planned 6 months out into the future to ones that are email-based. We've seen ripple control technology in Germany, but there is this new language that's starting to be used in the United States called OpenADR, and it's really there to help facilitate live ongoing demand response events in real time. So while I wouldn't say that this is necessary for most charging and energy management systems right now, watch this space as more EVs are brought online and more renewables are brought online. I really expect demand response to become more and more important. Depending on your application, I would say that's probably a transit or a school bus fleet doesn't really care about billing, but someone who's operating a charging network, say in a parking lot for various consumers, billing is an important part of that. I've seen OCPP proxies be used a lot in this space, and generally you'll see a charging energy management supplier partner with a third party to provide that billing software. So those data sets are kept separate for security reasons. Another subsection that usually charging energy management sometimes integrates with are the microgrid or the building energy management systems. Generally, in this side of the industry, Modbus is what's going to be used. Modbus is a language that was designed for PLCs or programmable logic controllers in 1979 by one of Schneider Electric's previous companies. Really, a programmable logic controller can be found in anything that has any minimal level of intelligence. These are the types of computers you'll find in photovoltaics, energy storage systems, building management systems, energy meters. And so if you are thinking about any sort of integration there, you want to make sure you get a charging and energy management system that can speak Modbus. Charging stations, though, have their own protocol called OCPP, with the most widely used one being OCPP 1.6J, which I will talk about in a second. And then the communication between the charging station and the bus is generally handled by ISO 15118, or you might have heard of VDV 261 or 463. VDV is actually the German transportation industry group, and they act as both an industry group and also a standards organization. So if you're wondering what VDV stands for, it's a German acronym. So more on open charge point protocol. OCPP is a manufacturer neutral license-free communication protocol. It was developed by the Open Charge Alliance about 10 years ago. It involved a partnership of more than 160 companies worldwide. And currently, almost all leading manufacturers of chargers equipped their charging stations with some sort of OCPP capable technology. And I put an asterisk on that capable technology to come back to it really quickly. But which one is used most often now? That would be OCPP 1.6J, with the J standing for JSON. JSON just means that it opens up a communication channel that is live, that doesn't need to be refreshed, kind of like a chat program. As of right now, only OCPP 1.6 can be certified. 2.0 and 2.01 are out, but they cannot be certified and tested. If you do have any old chargers on site, you'll want to check whether they are 1.5 or 1.6, as OCPP 1.6 is not backwards compatible with version 1.5. And I've put the Open Charge Alliance's website here for easy access, because I do think it's one of the aspects of charging energy management that people would be benefited by doing a little bit more extra study. And that is because OCP certification causes some problems in some projects. And that's because OCPP certification kind of works like Girl Scout badges. In 1.6, there is a core profile, and then there's a bunch of other profiles with names like smart charging, remote trigger, local authentication lists. And to say you're OCPP certified, 1.6 certified, all you have to do is have that core set of functionality. However, to be agnostic and for a charger to be able to be controlled by a third party, you really pretty much need, all of those profiles, or in my analogy, all of those Girl Scout badges, to have it really fully integratable. And so you can think of it and say, I need my OCPP to be 1.6J full stack certified. I think the other term, but I would have to be triple checked on this, is called a full certification. There's also a little bit of kind of industry confusion on exactly what that means. People generally try to use OCPP language in their RFQs to mean interoperability. However, this has been used by a few companies in a way that I think is not as very clear. Certain companies will say they're OCPP 1.6J certified. However, they will then, refuse to work with another charging energy management company, as obviously they want a captive audience and want to sell their software. In my opinion, that's like being told that you should learn German. You learn German, and then you refuse to talk German to anyone else. So I advise, buyer beware, and make sure that you check that your charger manufacturers are willing to work with third-party charging and energy management software. A lot of charger manufacturers are also starting to push 2.0 if they have it. However, there's only a few charger manufacturers with about one charger each that have 2.0. And really right now it's mostly used for marketing. Most charger manufacturers have 1.6, most charging energy 1.6. And to be frank about it, some large charger manufacturers still don't even have a full 1.6 version. So if you were to ask me, what should I be buying right now, the answer is 1.6. I think in about, 7 to 10 years, you should be buying 2.0, but it is a maturing standard and that can sometimes cause confusion. Another thing that I think often gets overlooked is the importance of resiliency. The mobility house primarily targets what I would like to call critical fleets, and that's, school bus and transit. And I would also add to the list on what I would consider critical is emergency response vehicles. Fleets where you definitely cannot have a situation where they run out of charge. But I mean, I would also say that I've never talked to a fleet manager who doesn't think whatever type of fleet they have is critical. So if resiliency is important to you, I will say that you're probably going to have to go with a more expensive solution. As when you build in resiliency, you build in cost. But if you were going to spend your money on 3 things, I have them here. 1, buy a solution with a local controller. That's important because having a local controller on site allows your charging to still be managed when the internet goes out. And I'm sure I don't have to say to anyone, how unreliable Wi-Fi is. It also gives you a lower latency, otherwise known as you're able to react faster in real time to real data. It also facilitates over-the-air updates to your chargers and to your charging energy management system. Another thing I think you should spend your money on is an Ethernet connection to each charger. It's 1 point less of failure and enables better data transfer because, giant parking lots are generally not the best place for Wi-Fi. They can be in parking decks that are giant concrete structures or with a lot of metal around, and obviously vehicles passing by and getting in the middle of the signal. Another thing that you should look at it for is real-time monitoring with a team that's watching your chargers. This is because charging and energy management solutions, basically have a lot of computers in them and involved. And so, a level 1 technical support that's able to, turn it on and off again actually can resolve, and what we found, approximately 90% of the issues that come out. Also, in terms of issues, getting notifications in real time from this team is really important to getting your site back up online as fast as possible. My final kind of lessons learned in this space is that there are a ton of people and companies and partners that have a role to play in your electrification process. We can see it from this graphic that, you could look at a electrification project in 3 phases, and you're going to have to talk to different partners in each one of those phases. Make sure you pick a charging and energy management supplier that has worked with partners before and that is used to doing these sorts of projects, as that'll save you a lot of time and a lot of headache. And I also have some examples for you of where charging and energy management has been used and what exactly it's allowed these projects to do. The first one being King County Metro, which is the largest transit bus charging site in the United States. You can see that King County Metro is using 3 different types of chargers with 3 different types of manufacturers. It is also having its grid limitation overcome by charging and energy management. On site, there's only about 2.5 megawatts worth of power, where if you took the sum total of their chargers on site, it would be about 4.63 megawatts if you were to turn them on all at the same time. And so because you have a charging and energy management system there and in place, that allowed Kings County Metro to not have to upgrade their transformer, saving them approximately $1 million, as well as approximately 2 years lead time. We're also expected to save Kings County more than $100,000 a year in operating expenses. This is, by doing that demand charge avoidance and time of use rate avoidance as well. Another example on the school bus side of things is the Stockton Unified School District in California. This site has been active for 2 years. We can see 2 different types of charger manufacturers being used there as well. ChargePilot is optimizing with their time of use rate, and is also supposed to save them over $500,000 over the next 5 years. The Mobility House was able to collaborate with Schneider Electric and CTE to make sure that they had a full scope charging system that was going to meet the needs and do the most important thing, which is get the kids back and forth to school every day. So all of this to say, when looking at a charging energy management system, I think there are really 3 features that you got to understand and want to think about pretty deeply on. The first being resiliency, the second being interoperability, the third being how it plays within your existing ecosystem. And why do you care about that? Well, one, you want to make sure your charging energy management system and your chargers are working so they can charge your fleet. The second is you want to have options in your purchasing both now and the future. You don't want to become captive to one company. And the third is you want to make sure your charging and energy management system integrates with what you have now and what you'll have and purchase in the future. With that, I've also picked out a few other lessons learned and other resources that are not directly charging and energy management focused, but I'd be remiss if I didn't mention them. If you're wondering, hey, I don't want to do any grid infrastructure upgrades and I want to know what type of charger I could put on my site right now, go look at the amperage that you have available on site. Usually you'll have one of these 3 amperages listed, and you would need to pick a charger that fits that amperage. Usually an AC charger will use 208 or 240, and a DC charger will use 480. Also, make sure you understand your overall plan and your overall goal. Ask yourself questions like, do you want to integrate solar? Do you want to do some sort of vehicle to grid technology? How many vehicles are you planning on electrifying and when? And what is their duty cycle? Knowing these answers up front will help all of your partners give you the successful outcome that you need. Under the whole partnership idea, find a person both internally and externally to help you with your grants. This space is seeing more money than it ever has been, and it would be a shame if you qualified for those types of grants to not get them and to not apply for them. Fourth, you're going to need a project electrification lead. This is not something that you want to have led by committee because there are so many moving components, and keeping your goal front of mind is what's really going to make you successful. There are going to be conversations with multiple parties, even if you hire an EPC to be a single point of contact. So make sure that you're prepared for that and make sure you have a person assigned to be having those conversations. And finally, talk with people who've succeeded at electrification. The nation is awash with pilot projects, and you want to make sure that you are taking lessons learned from pilot projects that are in your industry so that you can get the best outcome possible, because electrification is such an important thing that is happening to the transportation industry. Finally, I wanted to leave you with 3 little nuggets. The first is my favorite of all links, and that's the NREL Electrifying Transit Guidebook. While it is written for a transit audience, I think NREL does an amazing job of just, putting in really good lessons and covering the topic and what you got to think about of electrification really, really well. Also, I've just linked the Open Charge Alliance's website where you can find the OCPP standards and find out more about what I mean when I say OCPP certification. And finally, if you've liked anything in this presentation and you want to see more by the Mobility House, I've put our website down below. With that, I wanted to thank you all for your time, especially Rick and Tony for having me today. And for questions on this presentation, I've left my email, and then for any other questions, you can reach out to our sales team. And with that, I will pass you guys back to Rick.
Well, thank you. I think First thing I would do is again, Elizabeth, thank you very much for the presentation. And again, today's webinar was just kind of like a basic 101 on there. We're looking to maybe do something a little bit more in depth, but we would like to have some feedback from you all on what else you would like to see in the energy management of specifically more chargers and all that. But we'll open it up to anybody who has any questions. You can unmute yourself and you can go ahead and ask the question if you would. Well, you must have done a good job there, Elizabeth.
I hope so.
So I'll lob a softball question in this, Tony Bandiero. So what do you see as the general, amount of vehicles that a fleet must have or whatever before they start considering this kind of stuff? If you have one or two light duty vehicles, it may not be you may not need this whole energy management, but when you talk about a fleet of school buses or you're talking about a bigger fleet with larger, heavier batteries, you're probably gonna have to think about this more. So what are you seeing right now, and what's the trends, and where, do you need one for light duty vehicles and things like that?
I think the question is more based on application and your power connection on your site. For instance, an example where you could have a really small amount of vehicles is in a building with multiple loads, right? If you have both your chargers on the same load as your building load, well, then you want to be really careful when, you are charging your vehicles. So that would be a case where you wouldn't actually need a lot of vehicles to make charging and energy management make sense. However, I will say, the more power and the more vehicles and the more complex the duty cycle of these vehicles, like when they have to be charged by, the more charging and energy management is going to play a critical role. So I would suggest, instead of charging energy management or no charging energy management, the level of complexity of your situation will determine the level of the charging and energy management you need.
Okay, that's great. And so I don't know, this is kind of a very, I'm sure it varies, but where everybody's cost conscious about everything, so and you don't have to give exact numbers, but generally, do you have a price range for your service, for your software? I mean, if it's a small to medium size project, is it one price? Or I know it's probably project specific, but what kind of pricing structure would someone expect from this type of service?
So you're gonna, going back to when I talked about resiliency, your costs are really gonna be affected by a couple things. One, how resilient the system is. A more resilient system is going to be generally more expensive. And then you're also gonna see charging and energy management solutions vary by type of vehicle and type of charger. To be fully frank and honest, I'm a sales engineer and I never have to deal with costs. So I'm gonna bat that one away because I couldn't give you an accurate number.
Right.
So do you, just a quick question, this is Rick again. We're working within our states, and a lot of states are on the NEVI stuff. And actually the state just awarded a number of DC fast chargers along the corridors. Would the management software, would you see that playing a role on the chargers that along the corridors, or more for fleets?
I would say that when that probably the NEVI chargers should be built out with charging and energy management in mind. However, in the first initial phase, it's probably not going to be as important because generally, I believe the minimum standard NEVI requirements is 4 chargers for 150 kW each. And probably, people are not going to be buying, 250 kW chargers and putting them in the place with the 150, and they're probably just going to have that minimum threshold. However, when, we want to upgrade these sites in the future, using a charging and energy management system would allow you to put more chargers on that same connection and control that site better. So I think it's going to be something that plays more of a role in, like, say, NEVI round 2 or NEVI round 3 than NEVI round 1. But I think if we want to make these charging sites, really play the role of gas stations, where you're probably going to need more than 4 cars being there, it is something to think about in the future. And as far as like fleets versus singular cars, anytime where you have a constrained grid interconnection or a utility rate structure that has time of use rates or peak demand charges, I would say some level of charging and energy management provides value, no matter how many vehicles are plugged in.
Yeah, I see, I sit and think about folks that can't do charging at home or on the road when we and probably a lot of these are going to be in the inner city, the community type things where parking is there for people coming to work in the day, but at night it could be also used as a central location for folks that don't have single family homes or driveways or places where they could put in chargers to do that. And so a management software would be good for that. Is that correct?
Yeah, I would say a management software would be good for that. For a couple of reasons. One, you want to be able to make sure that that building doesn't get hit by a ton of cost for giving out this service to, because inner city populations, but you also might want to be able to facilitate some sort of billing backend, and really anytime that you're going to have some sort of constrained grid infrastructure, because we have to remember that these buildings were not built out with grid interconnections or basic power gear and power transformers and switch gear that is able to handle all of the vehicles charging at full rate all at once. But we can use charging and energy management as sort of a bridging technology until we can build out the power grid to a larger size to accommodate all these electric vehicles. So it does have a space to play in basically helping the grid get more flexibility to deal with these new load types.
And I have one last question. Does management software, would it be good, or could it be used when we're talking other types of energy, such as solar and wind and stuff like that? Could that be integrated? Has it been integrated anywhere that
Yeah, actually, the Mobility House did just do a first of its kind project in Brookville, Maryland, where we were integrating charging and energy management into a larger microgrid. So go check out our website on that. I believe that had solar and some storage, but I'm not entirely sure. I know we also have worked with, I believe, Porto Santo, which is an entire island that was put on a microgrid that had all different types of generation. So charging and energy management as a controllable load has a big place to play in future microgrid integrations and more complex grid structures.
Okay, do we have, I'll give everybody one last chance if anybody else wants to ask a question. If not, please reach out to Tony or I, or Elizabeth. These slides and this video will be on our website and on at EPAC's website for future thing. We would really appreciate it, Elizabeth. I learned a lot already about energy management software, and we look forward to maybe having you doing another webinar in the future.
Yeah, any excuse to talk about electric vehicles.
Thanks so much. Appreciate it. Thanks
you.
everyone for showing up. And if you have any questions or need any other information, just contact us or Elizabeth and we'll be able to help you.
Thank you, guys.
Take care, everybody. Have a great day.